Good evening, Prof.
Good evening. Apologies for starting a little bit late. I thought we have even finished the program, awaiting the projects. Um, okay, I guess that this will be the last. This will be the last course. Others have finished, but the MPH being a generic program, has more courses. In fact, probably that is the reason why the MPH is a little bit more expensive. And also the fact that MPH is a internationally recognizable degree. So if you have an MPH, even if you go to Russia, yeah, the degree is the degree is recognized. If I say recognized, it will be as if I said other degrees are not recognized, but it is widely known. I think is the main qualification for public health practitioners. In fact, used to be a professional degree, and a professional degree because emphasis are actually placed on the competence. Okay, but for our own program is both professional and academic. So this is the last. The next thing we are going to do, there are two things that are outstanding. The seminar, which we are beginning to convert into research seminar, and then your project. So for this course, we have shadowed lectures almost throughout the week, but let's just see how far we can go, if we'll be able to take all the lectures, or if we'll tell you to read up certain aspects. But just bear with us. There are several conflicting things we are doing. Okay. So today, this course is on environmental and occupational health. We have been taught in the history of public health, and you notice that at the beginning of public health is environmental health. Environmental health is the beginning of public health. Our public health was almost entirely environmental health, until others. Then other specialties became added, especially epidemiology, which is currently the science of public health. Okay, so this course is environmental health, and we are also going to talk something about on occupational health. So it's occupational and environmental health course. So we are going to start the introduction. We are going to introduce you to the concept of human ecology, environmental hazard, environmental sanitation, sustainable development. And if we still have time, we'll go into water and so forth. So we have to start with ecology. Ecology has to do with is the relationship between human beings and their environment. The relationship between human being and their environment, and what is called the ecosystem. The environment is usually divided into three. It's usually divided into the physical, the biological, and the social environment. The physical, the biological, and the social environment. And later, when we take the occupational health component, in occupational health, there is a tendency to divide environment into five instead of these three that I have mentioned. So in occupational health, there's a tendency to subdivide the physical environment into physical, chemical, and mechanical. Physical, chemical, and mechanical, the 5 components of the environment. Okay. So, but for this environmental component, we want to talk about the three components: the physical, the biological, and the social environment. The physical environment has to do with is made up of both the natural environment and the built environment. The physical environment is subdivided into natural environment and the built environment. The natural environment is, of course, made by God, while the built environment is made by man. The natural environment consists of or includes the land and its topography, the natural resources, and the climatic condition that influence the vegetation and the presence of the flora and fauna. Okay, so the natural environment has to do with the land and the climate, and then the natural resources, the land, the climate, and the natural resources. While the built environment is made by man, and we can actually subdivide this built environment into the home and occupational environment, into the home and occupational environment. Occupational environment, or the work environment, the home and the work environment. The work environment is where we work, where we go to work in, and usually we spend about 8 hours in the work environment, and then we retire back to the our residential environment, our home environment, which is made up, which most times we spend about the rest of the day, that is 16 hours in. Okay, then the biological environment is made up of the living things other than man. The living things other than man. Usually we try to, in health sciences and everything, we don't like to, we like to give man a special classification. So the biological environment is made up of the other living things apart from man. And in public health, we are interested in the microorganisms, we are interested in vectors, and we were interested in some animals, especially animals that have the capacity of transmitting certain diseases to us. These diseases are called zoonotic diseases, and these are diseases that are transmissible from animal to man. And in the present world, these zoonotic diseases are becoming very, very important, because even wild animals are also important in this respect, because of the tendency for microorganisms that once only cause diseases in animals. They are now jumping species to affect man, such as the Ebola. So we are now, I think there are now a lot of interest in these animal diseases, so what used to be the zoonotic diseases. And right now we have what we call the One Health. One Health. One Health is it has to do with taking into consideration the animals, and they try to bring together Ministry of Agriculture, Ministry of Environment, and Ministry of Health to ensure that diseases that were originally in animals are also taken into consideration when we are considering human diseases. Okay, the social environment is completely man-made. Social environment is completely man-made and has to do with the relationship between persons, our interpersonal relationships, and it also includes the way we worship, the religion, our culture, our tradition, even the government and what we believe in. The social environment is very, very important. our interrelationship with persons. Okay, has to do with the social environment. But in environmental health, there's a tendency for us to deal more, especially with the physical environment. Okay. Then the other thing, we have talked about the components of the environment: the physical, the biological, and the social environment. And the next thing we have to talk about is what we call the environmental hazards. And I'm sure that you must have heard something about hazards. Probably in epidemiology. A hazard has been defined as anything with the capacity to cause harm. Hazard is anything with the capacity to cause harm. And we have these hazards in all the components of the environment. We have physical hazards, we have biological hazards, and we have even social hazards. So I'm sure you can give examples of these hazards. The physical hazards, for example, the sun. If you walk under the intense sun, you can have heat stroke, and the problems associated with exposure to excessive heat. Okay, and if you are fair skinned and your skin doesn't have enough of melanin, that is the black pigment, you can have sunburns, etc. Okay, etc. So there are hazards, physical hazards, and biological hazards. We know microorganisms, especially those with the capacity to cause severe diseases when we are exposed to them. So there are the microorganisms are biological hazards, and then even social hazards. We have social hazards, the problems, social hazards, problematic individuals, bad government, of course. Yes, there are hazards. Communal crisis, they are all. Yes, no, communal crisis is the fallout of a hazard. Okay, so we have all those too. But in the environmental health, there's a tendency for us to sub-classify these hazards into two: the traditional hazards and the modern hazards. The traditional hazards are hazards that come from everyday existence, and they are most of them are macrobiological. Like if we drink water that is contaminated with feces, we can come down with diarrhea, and most times the diarrhea is due to microorganisms. Okay, so the good thing about the traditional hazards is that they manifest almost immediately, but they are curable. Traditional hazards usually caused by microorganisms, they manifest almost immediately, but the good thing is that they are curable. And then the other type of hazard are called technological hazards. They are slow poisons. They are usually produced by industries. And at times we may not even know that we have been exposed to them, and they are slow poisons. They take a long time to manifest, but unfortunately when they manifest, they cause diseases such as organ damage or cancers, which unfortunately are incurable. Okay, incurable. So for example, now when the UNEP reported benzene levels that are significantly higher than the regulatory limits. Okay, so you can go there, you can go to Okale, Eleme, and drink the water. You may not feel it. You may not feel the benzene contaminated water. You may not even have an altered taste. But the problem is that benzene is a known carcinogen, which means that 20-30 years after, the person can come down with cancer. So that is the problem with technological hazards. They may get into your body and you may not feel it, but after some years it may manifest unfortunately, when they manifest with incurable diseases like organ damages and cancers. Okay, so that will lead us to environmental sanitation. Environmental sanitation are efforts made to reduce the concentration, the levels of hazards in the environment to the extent that they are not capable of causing harm. They are no longer capable of causing harm. So environmental sanitation are efforts geared towards reducing the hazards in the environment to the level that they don't cause harm. Okay. Perhaps before I go into that, the concept of environmental sanitation, perhaps I have to introduce the concept of pollution. I must say that the presence of a pollutant is not pollution. Pollution is when the pollutant is present at a level that is capable of causing harm to health. So that is only when we can say that something has been, a place has been polluted. We can only say a place has been polluted if the level of pollution is up to the pollution is up to the level that will cause harm. Okay, so with that we can now go into the concept of environmental sanitation, which is to bring the level of the pollutant to the extent that it will not cause harm. For example, when feces contaminate water, it usually shows in as E. coli. It usually shows as E. coli, but we have billions of E. coli. So the cutoff point of fecal contamination that can cause diarrhea is actually 10 E. coli per deciliter. 10 E. coli per deciliter. So if it is below 10, we can say that that water is safe, even if there are still E. coli in that water. So environmental sanitation are efforts geared towards reducing the hazard to the level that they will not cause harm to most members of the community. Okay, and of course, environmental sanitation comes from the word sanitize, and to sanitize is to make clean. So environmental sanitation is basically to clean the environment to the extent that that environment will not constitute a threat, a harm to health. And usually we have the components of environmental sanitation, and it includes provision of safe and adequate water supply, proper sewage disposal, proper solid waste disposal, sewage disposal, food safety, good housing, control of air pollution, control of insect vectors, control of animal reservoir of infection, control of other hazards like noise and radiation, which is now being practiced under the Ministry of Environment. Okay, so I will introduce environmental sanitation. Okay, I'm sure that you are aware, you have seen this man before, Edwin Chadwick. He was the secretary of the Law Poor Commission, and he was the one that pushed for the promulgation, for the enactment of the 1942 Public Health Law, 1948 Public Health Law, that actually institutionalized public health practice in Britain and later in Nigeria. Okay, the other person we have to introduce is this guy, Isaac Ladipo Oluwole, who is considered as the father of public health in Nigeria, was the first African medical officer of health, and he was the one that actually started the environmental. We can say he was the first medical officer of health, and he actually went about institutionalizing the practice of public health, starting with the recruitment and training of sanitary inspectors who became known as his boys, or as his boys, Oluwole boys or Wole Wole. Okay. So we have talked about that. Then the other thing we have to also talk about is environmental sanitation is the present, for the present. We have to also introduce you to the concept of sustainable development. Sustainable development is the development that doesn't compromise the ability of the future generation to also meet their own developmental aspirations, which means that some people have actually called sustainable development that environment is the loan we borrowed from the future generation, which means that we have to repay it. We have to use the environment in such a way that our children and our children should be able to also meet their environmental needs. So in that case now, that means that we are permitted to exploit crude oil, but we should do that in a way that will not pollute the environment. Unfortunately, we are not doing so. We are not doing so with oil bunkering, artisanal refining, unscrupulous oil companies polluting the environment, destroying the mangrove, polluting the water, and thereby making it difficult for fisher folks to actually earn a living. For example, I don't think there is any fisherman fishing in the inland waterways of Nigeria that can actually make a decent income because of the level of pollution. Which means that our development is not sustainable, because we have polluted the environment so much that the future generation may find it difficult to cope with. Okay. So I have quickly done the introduction. We have talked about environmental hazards, human ecology, environmental hazards, sustainable development, environmental sanitation. I don't know if there are questions or comments. This one that the participants are capped at 100. I hope this license is able to go accommodate above 100. Do we have any question, any comments? Any question, any comments?
Prof, most of them are outside the...
Okay, let me get in touch with Daniel so that he'll be able to raise it. Yes. Okay.
Prof, good evening,
yeah,
sir.
good evening.
Please, sir, I did not actually understand the section we were talking about before something can become pollutant. I didn't actually get it because of network. Can you please throw more light there before it can cause pollution or become pollutant? Sorry.
Before it can be considered a pollutant, it will be above the level that it will be up to the level that is capable of causing harm. I don't know if you understand that.
Yes, sir.
Yes.
Thank you.
So, yes, because it's not just the presence, but the presence up to the level that will cause harm. At times, they have what they call the guideline values. Guideline values are the maximum permissible levels. Okay. Do we have any other questions while we see if anyway, I'm sure that he's going to work on that. Okay, so we can continue. We can continue. So I think this environment. I don't know if we have even the interaction between us and the environment. Okay, I think it has exceeded now, which means he has worked on it. Okay, so the next thing now is we have the environment, our interaction with the environment, of course, we know that we are in a tropical country. We're in a tropical country because we are very close to the equator. We are very close to the equator. And because we are very close to the equator, the sun is shining. We are having the full blast of the sun. And because we are having the full blast of the sun, this environment is hot. And because it is hot, it evaporates water, and then that's why we are hot and humid. And that hot and humid condition makes it difficult for us, for the sweat to function effectively, because the sweat will have to evaporate to cool our body. Unfortunately, the humidity, the moisture in the air affects that, and that's why we sweat without even feeling cool, without cooling our body. So in Nigeria, we have different types of climate. The climate of Nigeria can be divided into four. We have the tropical monsoon climate, the one found in southern Nigeria, especially along the coast, where the rainfall is high. Because the rainfall is high, the moisture in the soil is able to sustain plants all year round, including during the dry season. And that's where we have green vegetation all through the seasons. We have green vegetation all through the season. So this tropical monsoon climate, they have rainforests. So you have forests with a lot of trees and these animals, wild animals. And in places where they have rainforests, there are certain diseases that are associated with rainforests. For example, jungle yellow fever. There is a yellow fever that occurs. I think it was originally amongst arboreal monkeys that live on treetops. But once in a while, those mosquitoes, they come down and bite and transmit yellow fever. And of course, Ebola, mpox, and the rest, they are all associated with rainforest. Okay, then we have the next is the tropical savanna climates. Tropical savanna climate are this climate is found in the north central and the upper part of northeast, northwest, south. This zone, they receive less rainfall, and because they receive less rainfall, the moisture in the soil is usually not enough. Not enough to go around the year. Usually not enough to go around the year. And so because of that, they usually cultivate grains, because grains they have a shorter life duration. Within 4-5 months they are matured for harvesting, and that's why those crops are cultivated in that climate zone. The problem now with that climate zone is that because of the dry season, the environment is almost is dead. Should I say dead during the dry season? because almost everything will turn brown. Almost everything will turn brown, even making it difficult for wild animals to survive. And that's why we are beginning to have higher incidence of Lassa fever, because during the dry season, these rats, they move from the wild into people's dwelling. Okay, then the third climate we have in Nigeria is semi-arid, and this climate is found in south, northeast, and northwest. They receive very short rainfall, and with the climate change, they are even suffering. They are even suffering from encroachment of the Sahara Desert, and even large pool of water bodies like Lake Chad is shrinking. In fact, it's said that Lake Chad is currently just about 10% of its original size because of climate change. So they are currently having problems with water. They are currently having problems with water. Yes. So the other climatic zone we have in Nigeria is island climate. And these highland climates are found in those mountainous regions, Jos Plateau, Mambila, Mambila, where that are more than 1,500 meters above sea level. So they have a climate that is almost temperate. They have a climate that is almost temperate because of their altitude, high altitude. So we have four climates in Nigeria, and these climatic zone, they actually determine how we use the environment. There are differences in how we interact with the environment. In the tropical monsoon climatic zone found in southern Nigeria, where you have rainforests. The rainforest provides food, but they can also be a source of diseases like mpox, like Ebola. Then we have the tropical savanna that receives less rainfall, and the problem is that during the dry season, the whole place is devoid of green vegetation, and that makes it and that is even worsening with climate change. And meaning that it is almost very difficult to carry out agriculture within that period, and even the deadness, or the fact that the environment is parched is even making it difficult for wild animals to survive in the wild, and a lot of them are moving into people's habitation and causing epidemic diseases like Lassa fever. Then the highland climatic zone, they have a temperate environment, a temperate temperature, because they are at least some of them are up to 1,500 meters above sea level. Okay, above sea level. I don't know if there are questions or comments with just these interactions. Yes, I don't know if there are questions or comments. Let me welcome those that were able to break the 100 participants mark. Do we have any questions or comments? You have the slides, so I'm sure that you can look at the slides too. Do we have any questions? Any comments?
No comments, sir.
Okay. Thank you. Okay. Well done. So, which means you are going to fly, and I was just thinking, should we even how many lectures we even have in a week? How many should we have in a week? Okay. Okay, so at the end of today, we'll find out. So the next, we'll just go to water supply, and let's just see how far we can go with water supply. Um, of course, we know that water is a fundamental human need. It's recognized as a fundamental human need by the United Nations. And because it's fundamental human need, it becomes responsibility of government to provide it, because it's fundamental human need. We need it to survive. And I used to say that when a government, we surrender our sovereignty, our independence to the government in exchange for the provision of welfare, for our welfare and security. Welfare and security. And one of those welfare issues, important welfare issue as a fundamental human need, is water. And governments all over the world, including even the Romans, they took it very, very serious. For example, when the Romans conquer, they usually build a city, an administrative center, and they provided water. Yeah, in fact, among the Romans, they said a place is not a town, except it has a pipe-borne water, public pipe-borne water. That is a water with house connections, public fountains, and public baths. And they were able to provide water make water available into people's homes. Okay, into people's homes. And they were able to do that not with sumo pumps, but with their own technology called aqueducts. So they went to great lengths. They went to great lengths to provide water to their citizens using technology, their own unique technology called the aqueducts. Aqueduct is so good. So good that it is still being used in some parts of Rome. In some part of Rome, some part of Rome is still being served by this aqueduct technology. Okay, so water is also important in public health. There are three things in assessing the water situation in a community. We have three ways of doing that. We look at the source of drinking water of a place. We look at the quantity of water that is available to members of the community, and then we look at the quality of the drinking water. So the sources, the quality, and the quantity of drinking water. So the sources are very, very important. If you tell me the source of drinking water of a place, I can tell you the problems that are likely to result from there. Okay, so the sources are important. And there are basically three sources of drinking water. The rainwater from above, the groundwater from below, and then the surface water that flows. Surface water which we can see. Surface water which we can see. All the other sources, all the sources of drinking water can be pigeonholed into any of these three sources: rainwater, groundwater, and surface water. Surface water, there are of two types: the ones that flow and the ones that don't flow. The ones that flow and the ones that don't flow. Okay, so the rainwater from above, and this rainwater, rainwater is available to, sorry, let me take this call. Let me briefly. Okay, so drink rainwater. Um, Rainwater. There are some actually there are some communities that rely almost entirely on rainwater. Yes, almost entirely on rainwater, and this community include those that are far from surface water. Those that are far from surface water, like some communities in northern Nigeria, they have to very far from surface water. Eh? Then we have communities with low groundwater level. Low groundwater level. Unfortunately, these communities are plenty. In fact, I went to Benue State and I was surprised that they were having problems with drinking water. Even when they were very close to River Benue, they were having problems with drinking water because the place is a little bit hilly, and because of that, the groundwater is deep. Is deep, is deep. So communities like that, hilly communities may find it difficult to get water, and then communities that are covered with salt water, like communities in the mangrove forest ecological zone of the Niger Delta, where you have communities that are covered with salt water. Remember what the marina said: water, water, but none to drink. So, yeah. So these are communities that rely almost entirely on rainwater. But remember that rainwater usually is usually available in during the rainy season. So, which means that these communities, they have abundant water, a lot of water during the rainy season, but little or no water during the dry season. So they have to find a way. They have to find a way to store the excess. They have to find a way to store the excess. And usually they have what they call the rainwater collecting system. Rainwater collecting system usually involves channeling water from the roof of their houses to a collection, a storage tank. In fact, I saw in Oromi, where they had to channel this. The storage tank is actually an underground pit, just like a well that is plastered, and they channel the water and get the water from there. Okay. So we also have communities that are dependent on surface water. For example, the riverine communities, the freshwater riverine communities, say of Orashi region, and then of Bayelsa, where the freshwater covered the whole place. So they had to. Unfortunately, surface water is usually polluted. Surface water is usually polluted with feces, with refuse, and a lot of other things. With feces, with refuse, and a lot of other things. And I think we have to also state that in Nigeria, in the north, most of their communities are located very close to rivers. Although those rivers are seasonal. Those rivers mostly contain water during the rainy season and dry up during the dry season. But the good thing is that you can still find water in their riverbed, dry riverbed. So if you dig if you dig into the dry river bed, you can still get water. So that is how. So most of the communities you find in northern Nigeria are actually located very close to dry river beds, rivers. Okay, then we have okay, the groundwater. Groundwater, you have to dig. You have to dig groundwater. You have to dig groundwater. But usually the groundwaters, at times they are they have a lot of metal contaminants, because the water in groundwater would have passed through the soil, and as they pass through the soil, at times they dissolve. They dissolve some of the content of the soil. For example, in Bayelsa has their soil has a high iron content, and that is why the water when they fetch the water, probably the water may be colorless, but once it's exposed to the air, it turns brownish as the iron moves, is converted from ferrous to ferric iron. Okay, so that is that. So that is the sources of drinking water, as we have said, are divided into three: the rainwater, the surface water, and the groundwater. And each of these categories can actually also be subcategorized. Like the surface water, you have those that flow. I hear in the Bible they call those flowing water living water, because they are less polluted than the stagnant water that is, for example, pond. Stagnant water, they are usually more polluted, because even when they are contaminated, they don't flow. They remain there. And continue to contaminate the water. Okay, so that is the source. The next one is the quantity of drinking water. We are also interested in the quantity. The WHO recommends that each individual should have access to at least 20 liters of water a day. 20 liters of water a day for his drinking water and sanitation needs. In fact, 2 liters for drinking and the rest for sanitation. And sanitation includes flushing the toilet, bathing, washing clothes, washing plates, and the rest. So we must know that this 20 liters is even the minimum. It's even the minimum, considering the fact that, of course, when you shower, you use use more than 20 liters. Use more than 20 liters. Or if you are using a bucket is about 10 liters. And you have to also note that if you are using a water closet system, the standard water closet toilet, a flush is about 10 liters. So these 20 liters is a conservative estimate. Okay? So 20 liters per person per day. Okay, but in public health, we see a lot of persons. And because of that, over the years, we develop shorthands. So instead of going into the community to measure the actual quantity of water they use, we use proxy measures. And one of those proxy measures is the distance between the source of drinking water, the source of the public tap, and the person's residence. And it is said that it shouldn't be more than 200 meters. But what is now currently used is the travel time, the time it takes to fetch water. And it's said that the to and fro journey should not be more than 30 minutes. The to and fro journey shouldn't be more than 30 minutes. So if you go to a community and you want to assess their water supply, and if you see a situation like this, what will this tell you? Conclusion: they have water problems in that community, because it is difficult to fetch water within 30 minutes. Okay, so when you are carrying out a study, when you are carrying out your research, so you are assessing access to drinking water in the community. You use the travel time. You don't measure. You don't tell them to tell you the quantity of water they collect per person per day. No, you just ask them how long it takes to fetch water from the common source of drinking water in the community. Okay, it can range from piped supply. A household is said to have a pipe supply if they can turn on the tap and then get water. That means that they don't even need to store water in their house, because anytime they need water, they turn on the tap and they get water. Okay, so the next one is the quality of the drinking water. The quality of drinking water. The quality of drinking water. And that will take us to what we call the potable water or wholesome water. Please, potable water is not water that can easily be moved from one point to the other. That is not the definition of potable water. The definition of potable water is water that is safe and acceptable for drinking. Water that is safe and acceptable for drinking. So potable water has two components: the acceptability component and the safety component. So the water is safe. What is the definition of that safety? The safe water is said to be water that will not cause you trouble, will not cause any harm to you, irrespective of the quantity you drink and how long you drink the water. Irrespective of the quantity and how long you drink the water, it will not cause you trouble. That is the safety. Whereas the acceptability has to do with the individual. And I dare say that acceptability is somehow related to the circumstance. Because water you can accept when you have abundant water is different from water you will accept when you have water scarcity. Perhaps if you are traveling to Libya, using Nkorowe, if you are traveling to Europe via Libya, where you have problem with water, even if you see it has to do with the portability. It has to do with the acceptability of water. So when you are asked to define potable water, please note the two components: safety and acceptability. Safety and acceptability. So there are standard ways of assessing the of the quality of water. Standard ways of assessing the quality of water. And there are four ways: the physical, the chemical, the microbiological, and the radiological qualities of the water. The physical, the chemical, the microbiological, and the radiological qualities of the water. The physical qualities, they determine the acceptability of the water, because it's what you see. And it includes the color of the water, the turbidity. Turbidity is the cloudiness or haziness of the water caused by tiny particles in the water. The taste of the water and the odor of the water. These are the qualities. These are the determinants, what we test when we are interested in the physical qualities of water. Okay, I must also say that when people carry out the studies, especially when they have recruited environmental scientists to help them carry out those studies, I must say that there's a tendency for them to include conductivity, and even pH and the other things as when they're assessing the quality of the physical quality of the water. That one is, those ones are important when you are doing ecology, especially ecology that has to do with that is not human. When we are talking about health, human health, We are not so much interested in even the pH. I know some people have spoken about alkaline water, acid, alkaline water, and the rest. But the thing there is this: that the body is a homeostatic machine. The body tries as much as possible to equalize itself, to equalize the situation. So when you drink water, for example, when you drink alkaline water, it gets into the stomach, and stomach is fiercely acidic. So if you drink that alkaline water, it means that it will increase the pH of the stomach. And what the body does, the body will just make effort to equalize, to bring it up to the working pH of the stomach, which is acidic. So when we talk about the physical qualities of water, when you are talking about human health, please tell us about the turbidity, tell us about the color, tell us about the taste, and tell us about the odor. These are the most important determinants, or they are more important determinants. Turbidity, the cloudiness, those tiny particles may contain microorganisms, and that's why we're interested in them.
Last one, doctor, for TikTok.
The color of the water is important. The color of the water is important because it is the color that determines acceptability. It's the color that determines the acceptability. We expect the water to be colorless, odorless, colorless liquid. And when we see a water that is not of that color description, there's a tendency for us to reject. There's a tendency for us to reject the water. So that's why we are interested in the color of the water. Of course, the taste is indicative. Taste, that our tongue actually controls what enters our body. Yes, our body. So if the water tastes odd, there's a tendency for us to stop, because it gives the impression of water that is contaminated. And then odor is related with taste, usually for something to reflect as the odor. It means that it has a significantly higher concentration in the water. So that's why we're interested. That's why we are interested in these 4 determinants: turbidity, color, taste, and the odor of the water. Okay, so the other one is the chemical quality. Chemical quality of the water. It contains the chemical contents of the water. Chemical content of the water. And then chemical content of the water is very important, because when we drink water, our body doesn't expect us to just drink H2O. It expects us to get certain nutrients, because water is for rehydration. Water is for rehydration. For example, when you sweat, you lose water and you lose electrolytes. So the body doesn't expect you to just drink water, drink H2O. It expects you to also take in some electrolytes, if possible. Yes, he expects you to take in certain electrolytes. So that's why we are also interested in the chemical quality of water, especially as some water sources have been contaminated by, say, heavy metals from industries. From industries, we want to test, we want to make sure that water will not cause us harm, that water will not cause us harm. Then the radiological qualities of water test the radioactivity of the water. It tests the radioactivity of the water. And this is mostly important with groundwater and surface water. groundwater and surface water. Groundwater in the sense that you have a lot of radioactivity inside the earth. You have a lot of radioactivity inside the earth. So when you drill a borehole, there's a tendency that the water may be radioactive if it contains some radioactive materials. And it must interest you that even chipping, the one we call chipping, the one we use to build our houses, that the chipping is a little bit higher, has some radioactivity that is higher than normal. Higher than normal. So we have to also tell. And then the surface water, because of contamination from anthropogenic sources, human sources, like X-rays, waste from radiology departments. Radiology department, they do X-rays and they use other irradiations, and these can contaminate. This at times they indiscriminately dispose this waste. They indiscriminately dispose this waste, and it can find its way into our water body. And then in the Niger Delta, these oil companies, they produce waste. The crude oil contains what we call naturally occurring radioactive materials, and usually they are discharged into the water bodies. They are discharged into the water bodies, contaminating them and making them difficult, and making them radioactive, which means we have to be very, very careful with such water bodies. Okay, I have this man. I don't know. Some of you would have met him. My man, Professor Awori. He has done a lot of studies. In fact, some people call him the professor of background radiation. He has done a lot, and he has found out that a lot of the places, a lot of our communities, especially flow stations in Niger Delta, are radioactive. Okay, then in public health, we are very interested in macrobiological quality, where we are looking for fecal contamination. Fecal contamination is indicative that water has been contaminated with feces, and that feces can be from somebody with cholera, somebody with other diarrhea disease. So we want to, in public health, they are interested in finding out whether the water has been contaminated with with feces, and the indicator organism is E. coli. The indicator organism is E. coli. So they look for E. coli. They take water samples and look for the E. coli, and this is what they do. Those of you that registered in for the short course on public health laboratory would have noticed that in public health they take samples and then they test samples. So for water, usually they test the sample for fecal contamination, and when they do that, they are actually looking for the presence of E. coli. I don't know if there are questions or comments. We have talked about this water. Do you have any questions or comments? Questions, comments? If there are no questions, then he makes it worthwhile to just give you the slides which we have given, and then you can actually read off, or we can even pre-record. We can even record the lecture and give it to you, especially as we have conflicting activities. Okay, so if there are no questions, we'll be encouraged to do that. Okay, so we go to water-associated diseases. These are diseases that are associated with water. Diseases that are associated with water, and they are of 5 types: the water shortage, the waterborne, the water impounding, the water arthropod, and the water chemical diseases. The waterborne, the water shortage, the water impounding, the water arthropod, and the water chemical diseases. We are going to look at them one after the other. We are going to look at them one after the other. The waterborne diseases are infections acquired through the drinking of contaminated water contaminated with microorganisms. And yes, so water contaminated with microorganisms. So and they include a lot of them viral infections like polio and hepatitis A, potentially epidemic diseases like typhoid and cholera, and parasitic diseases like amoebic dysentery. So these are waterborne diseases, and we get them from drinking contaminated water. The next are the water shortage diseases, which are diseases due to that one acquire that people get because of shortage of water. Short. The water is either short, lack of water, making sanitation difficult, or when we use contaminated water for bathing. For example, crude oil pollution. In crude oil spills, if the water spills into the river and people use the river for bathing, it can lead to chemical dermatitis. Yes, chemical dermatitis. So when it has to do with shortage, the water is not enough, so people may not have a good bath, and this can be this is common in northern Nigeria, and it's associated with trachoma. Trachoma is an eye disease that is associated with dirty environment that helps the breeding of house flies, and these flies, they like to suck. They feed on human bodily secretions like they feed on bodily secretions like catarrh and eye discharges, and unfortunately, and as they are feeding, they just transmit trachoma, and this trachoma can lead to blindness. So this water shortage disease. Water impounding diseases are diseases that you get from impounded water sources. Impounded water sources are water sources that don't flow. Because they don't flow, they are usually very contaminated. Very, very contaminated. They are rich in organic waste. And because they are rich in organic waste, the aquatic animals like aquatic snails, they thrive in them, and that's why they transmit, and then they thrive in them, and then transmit those diseases that are associated with them, like schistosomiasis and guinea worm. Okay. Then we have the water arthropods. Water arthropod diseases are diseases that are diseases caused by arthropods that breed in water. And water arthropod diseases are diseases transmitted by arthropods that breed in water, and they include the mosquitoes. We have we have three species of mosquitoes: the Anopheles, the Aedes, the Culex. They all breed in water, but they transmit different diseases. The Anopheles mosquitoes, they transmit malaria. The Culex mosquito, they are biting nuisance, but they are capable of transmitting lymphatic filariasis. While the Aedes mosquitoes, they transmit yellow fever, dengue fever, Zika viral Zika fever, and the rest. Okay, so we also have others like Similarium black fly that transmits onchocerciasis. Okay, onchocerciasis. Okay, so we know these water and arthropod diseases. Then we have water chemical diseases. These are diseases that arise as a result of either the excess or lack of certain chemicals in water, either the excess or lack of certain chemicals in water. And they include this metamoglobinemia. This is a condition found in bottle-fed infants whose infant formula is constituted with water containing high concentration of nitrates. Although, yes, anyway, thank God for exclusive breastfeeding. Thank God for exclusive breastfeeding. And thank God that we have our dark skin, so we may not notice it. But high nitrate levels have been found in drinking water in Enugu and in Aba. But I know that several other Nigerian towns, they have that, especially when the soakaway is very close to the very close to the borehole. When the soakaway is very close to the borehole, you have that. So you have it in communities where it is yes, in communities where perhaps the borehole is fairly easy, fairly cheap to dig, like in several parts of the Niger Delta. So if it is very close to the septic tank, the water from the septic tank will be coming into the borehole, and that is probably why you have that high concentration of nitrates. Then, but the classical water chemical disease is the fluoride, has to do with fluoride. Excess fluoride is needed for strong teeth, but lack of it will result in tooth decay. The teeth will not be too strong, but excess of it will result in what they call fluorosis. Fluorosis will usually manifest as discoloration of the teeth. I'm sure that you may have seen somebody with a teeth like this, teeth like this. But I must say that in present day Nigeria, it's not usually the fluoride. After all, who give us pipe-borne water? The government, they don't supply us with pipe-borne water, so they may not have been added. They wouldn't have added fluoride. Okay, so but the most common cause of fluorosis in Nigeria is probably the use of toothpaste. And that's why children are or should be given small quantity of toothpaste, because they swallow. Toothpaste contain lots of fluoride, and that's why we are not encouraged to swallow the full instead. But children may swallow and can get high doses of fluorides from that. And these fluorides can then affect their teeth, as shown in these pictures. There are other ones that are very interesting. For example, saline intrusion. Saline intrusion is becoming a problem. Saline intrusion is becoming a problem with global warming and excess exploitation of groundwater. And so, which means that our drinking water is becoming salty. And studies have shown that communities that drink, whose water supply has a large quantity of salt, which has water supply is high in salt, are likely to have a higher prevalence of hypertension. Okay, and then And then, of course, in Niger Delta, where pollutions, oil spills are also common, and even in communities where they do artisanal mining, contaminations are also taking place. Contaminations are taking place, especially as chemicals like mercury are being used to process the gold, for example, process the gold. So we are getting the drinking water is increasingly getting contaminated, and of course, even up to recycling of batteries. Batteries, they contain a lot of lead. So if we don't recycle them well, or even throw the battery into our rivers, we can get high levels of such chemical contamination. Then, okay, so I don't know if there are questions or comments on these questions or comments.
Good evening, sir.
Yes, madam.
I have a question, sir.
Go ahead.
Okay, sir, you said when we sweat, we lose water and electrolytes. So I don't know whether should something be added to our drinking water, because we say we should not just take water to, that is not only what we are supposed to replenish, since we are losing water and electrolytes. So how can we get the electrolyte that is being lost as we sweat?
Perhaps we can get from our food. Yes, we can get from our food. But the ideal, for example, when people involved in sporting activities, usually they don't drink that ordinary water. But even we are also beginning to have some. I don't know. Have you tested a Nestle water before?
No, sir.
Okay.
Yes,
Okay.
sir. I've tested
Yeah.
it.
Yes. And you you know that it tastes a little bit different.
Yes, sir.
It contains
Yes, sir.
electrolytes. Contains electrolytes. Okay.
The green cap, sir, the green cap.
Yeah, I think Nestle is actually very very strong in nutrition, so that's why they have those. Eh? They have those. Okay, thank you at least for breaking the monotony. I was getting tired though. I derive my energy from the interaction. Okay, so we go to the interventions. Sanda. Hello, Kulu.
Yeah, good evening, sir. Thank you very much, sir.
Yeah.
My question is a rider on the first person's question. As public health practitioners, how do we support the community to replace the lost electrolyte through sweat? Probably most of them are farmers or hunters. They sweat a lot. So how do we advise them to replace the lost electrolyte in their bodies? Thank you.
We don't want to tell them to add salt, because anything that has to do with salt will increase the blood pressure. Fruits will be all right.
Yes, sir.
When I was growing up, and anytime we go to farm, after we take a break and we forage, we go and get fruits and all those things. They are better. They will replenish us better than yes. But I'm sure that the body craves. The body is a wonderful machine. If you take water, I don't know. At times, some people would have felt it that you can take water and you still feel thirsty. Is your body's way of telling you that this water where you don't take, it's not enough. It's not enough. Yeah, but by and large, most times we eat and we drink. Sorry, we drink and we eat. So the electrolytes we don't get in the water, we may get in the food. And to also tell you, a lot of the water we drink, they also have some electrolytes. They also have some electrolytes. Okay, hello, Pamela.
Thank you, sir.
Yes, sir.
Thank
Please,
you.
I just want to find out, in the process of sinking a septic tank and then a borehole, what would be the acceptable distance between the septic tank and the borehole in a 100 by 80 plot? Thank you.
Okay, that's 100. Okay, yeah, we used to say that it's about 100 feet between. That is 30 meters, 100 feet. Yeah, that is what is stated, and yeah, that is what is stated. But when you do it, especially in Nigeria, where we are all our own local government area, we provide our water, we provide our, we take care of our sewage. You can do the spacing only to find out that your borehole is separated from the septic tank of your neighbor by the fence. So that's why in better societies they have other means. Pipe-borne water should be responsibility of the government. Should be responsibility of government. And then the sewage should also be taken care of. People, even Gaza has a sewage system. I think we will get to that. Gaza has a sewage system. So people in Gaza, they don't have individual septic tank. But everything is collected and then sent to a sewage treatment plant and taken care of. Yeah. Okay, so that is that. So we'll go to let's look at interventions for safe water. Remember, we said that it is for first is responsibility of government, and what the calculation should be is 20 liters per person per day. So if it is if you are in charge, if you are, say, a local government area, and you are in charge of a local government of 100,000 persons, you know that you have to provide is it 2 million liters of water per a day? Yes, 2 million liters. And that is what? That is the target. That is the target. And then the next thing now, how do you provide this water? And please just note that we should begin to advocate that the government should have a minimum package. A minimum package. You will tell them, perhaps we have to decide, oh, government, what you are going to provide us water, provide us sewage disposal, good sewage disposal, refuse disposal, ensure education, quality education up to the primary, up to the junior secondary, then health facilities, healthcare up to. We can tell them that these are the minimum. It's only when you have provided all of these that you can go and do other things. Perhaps we should do that. And so when it comes to water, it is per capita calculation, per capita person, per capita. So if you have a local government of 100,000, you should know that you have to provide 2 million liters of drinking water a day to residents of that local government area using different sources. Using the different sources we have talked about: rainwater, groundwater, surface water. Rainwater, groundwater, surface water. Rainwater, we have to, you collect the water, especially during the rainy season, store it. So if it is groundwater, there are two ways of mining groundwater. Either borehole or hand dug. Hand dug, because it's hand dug, the hole is bigger. The hole is bigger. And because the hole is bigger, you cannot go too far. If not, the pit will just collapse on you. The problem with a hand dug well is that the water, the deeper the water travels, the cleaner the water. Not cleaner. Let us say cleaner. Cleaner in the sense that the microorganisms will be filtered off by the soil, because soil is a very good filter. Okay, so the deeper the better. The deeper the better. The deeper the better. So with hand dug well, the only thing with hand dug well is that you have to make certain provisions. You have to ensure that the water runoffs don't flow into the water, into the hand dug well. So you have to provide a parapet. And if, as much as possible, if you can plaster the surfaces of the well up to the dry season, yes, it means that the water you will see in the well would have passed through the whole depth of the well, and that will make the water better, cleaner. And as much as possible too, you will restrict the number of buckets being used to draw the water. Because the buckets, if you allow all commands affair, you may get buckets from all over, from the toilet and all those unclean places, and therefore the water can get contaminated. So you use probably a single bucket, and you use a single bucket, or you use encourage people to use special water drawing vessels. Like in the north, when I did my youth service, they have what they call buga. They have, I think it's made with plastic tube. Sorry, the tube of a vehicle, of a motor vehicle tire, and they construct it. And it means it's just perfect. It's only used to draw water. And then if you have more money, you can put a pump. You can put either a manual pump or you can put an electric pump. And you can actually, once in a while, you can chlorinate the water in the hand dug well using this bottle. Put a plastic bottle, puncture hole, put sand, pour bleach into it, and then lower it into the well, and the chlorine from the bleach will slowly seep into the water, disinfecting the water. Okay, for those in the borehole, you have to also take precautions. The most important is to have a good spacing between the septic tank and the borehole. And the problem with the water borehole is that the deeper you go, if the water as it travels, it can dissolve minerals. So you need to, although it doesn't have a lot of microorganisms, but it can dissolve minerals. So the best thing, so you may have to add some water purification methods, especially reverse osmosis, to to reduce the concentration of some of these dissolutes, some of these contaminants. You can use this reverse osmosis. Then surface water is very, 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 very contaminated, very, very contaminated. In this course now, we actually have the picture test component of this course. We have the picture test component of this course. You're also going to have it. You may be given a picture like this and then be asked to identify the sources of contamination, of the surface water. Yes, surface of contamination. And then I think three sources are obvious. If you have not been to the Niger Delta, you may not identify this. This one is a pier toilet, also called a jetty type toilet. This is a toilet. So this is a source of fecal contamination. These are refuse, solid waste, so contamination. Then they are washing. So they also introduce contaminants into the river. Okay, so for you, but the good thing about surface water is that it is the largest quantity of water. It contains the largest quantity of water. So if we want to supply a big town like Port Harcourt, like Lagos, like Abuja, we can't do that using groundwater. We can only do that using surface water. So, which means that we have to find a water purification processes to do that. And we have some of them that when we use, we can actually purify contaminated water, including even sewage water. We can purify sewage water to the level that it is drinkable. If we apply these different purification methods. And so the methods include abstraction and storage, plain sedimentation, also called primary sedimentation, slow sand filtration, coagulation, flocculation, and secondary sedimentation, rapid sand filtration, aeration, and disinfection. These processes, when we apply them, very contaminated water can actually be made pure, potable for drinking. Abstraction and storage. When you store water for some time, almost all the pathogens will die. In fact, most of the pathogens that cause disease in human beings, they cannot survive outside the body for a long time. So the first step is to store the water. Store the water for about 3 days, and most of the disease pathogens will die, because they need to stay in the human body to be alive. So if you store for 3 days or so, they die. So the next one is the sedimentation. You store the water. As you store the water, solids will drop to the floor. And they are filtered off. Okay, so this one is called primary sedimentation. The next step is slow sand filtration, where you pass the water through a filter, a sand filter. And this filter contains sand of different diameter. The upper part contains fine sand, and then the lower part contains gravel. And this slow sand filter is able to filter not just the solid materials, but they have the capacity of killing most of the microorganisms in the water. Then we have coagulation, flocculation, and secondary segmentation. This is the next step. And in this next step, you add a coagulant. A coagulant is something that is a chemical, or something that can aggregate the small, tiny particles, gather the tiny particles to form larger particles, which now fall to the bottom, and then removed, and then they are removed. Okay, so this is this stage, and after that you filter the water again. In this case now is here you are passing the water rapidly through another sand filter, and at the end of this process, almost all the solids have been removed. So the next step is to show the water to the surface. Allow the water pass through the surface, pass through a tiny film of water through surfaces. Another way of doing it is to create almost like a water fountain. If you do that, the process is to allow oxygen to get into the water, to enter the water. Allow oxygen to enter the water, and then in the process you remove the taste, you remove the odor of any odorous substance in the water will evaporate. Okay, the next step is to disinfect the water, and disinfection can be done using physical and or chemical methods. Physical methods include the use of ultraviolet rays. Use chemical methods, use chemicals, and there are basically two types of chemicals used. You have ozone. You pass ozone gas through the water. Ozone kills the microorganisms but disappears. It doesn't have a residual and disinfectant effect. But chlorine, when you add chlorine, it kills the microorganisms, but it remains. So if there is any recontamination, the chlorine deals with it. But the problem is that the chlorine in it will make it taste like bleach. It makes it taste like bleach. So that's why it is used differently. Ozonation is mostly used in packaged water, bottled water, pure water. They all use ozonation because you don't want taste. You don't want the water to have a taste. But the problem is that they can be recontaminated. Whereas pipe-borne water, where you supply the water using pipes to the houses of people, you want to have that residual disinfectant, so that if there is a broken pipe somewhere and there are leakages of sewage or anything, or dirty water, any other dirty contaminated water into it, you could the disinfectant, the residual disinfectant, usually chlorine will take care of such. So chlorination is mostly used for pipe-borne water supply. I don't know if there are questions. Okay, let me just quickly take this household. What we just discussed is for community when we are dealing with large quantity of water. But in some cases we deal with for water used at household levels, especially during epidemic of the waterborne diseases. We often encourage households to purify their water, and there are different processes, and they include boiling, filtration, chemical disinfection, and water filtration. So these methods can be used. These are common household purification methods. we start with boiling. Boiling is commonly recommended, and is effective. But you need to cook the water. You need to bring the water to a rolling boil for at least 1 minute. So you need money. You need money. It requires money. If you are using gas, you need to cook the water. I know that cooking the water may not be a problem to the person that is not paying for the gas. Yeah, but that is what you need. You need to cook the water, bring the water to a rolling boil to ensure that all the microorganisms are killed. But the problem is that there are, although boiling water is commonly recommended, but it is not the ideal. It's not the ideal. First, it costs money. Second, it can add taste to the water. You may not understand, but those of us that grew up in the village, where to drink tea, you have to boil the water with firewood. After boiling the water with firewood, you just know that the water will taste differently. Okay, so it's when you boil water, it can change the taste. And if you have hot water, you can't drink hot water, so you allow it cold. And if you have little children, it can be a source of accident. And then the boiled water can be contaminated. So it's not that after boiling the water, the water remains pure. It can be contaminated. If you use contaminated cup to drink it, you have nullified the effect. Okay, so these are the things we have to consider when recommending boiling water during an epidemic. Filtration can be effective, but not knowing fully well that the microorganisms are very small. A lot of them can pass through the pores of the clot. So we have to be careful, especially with clots. Clot filtration. Clot filtration is only effective against if you are dealing with things like cyclops. Cyclops that transmit guinea worm is effective. It's not a microorganism. It's actually an insect. That's why it's big enough. That's why it is big enough to be filtered off by clots. But there are other microorganisms must be filtered off with clots. Okay, so we have to note that. Then the candle filters. The candle filters can filter off some microorganisms. I don't know if you have seen this filter. It has a clay candle. You pour water at the upper. It has two chambers. One for the raw water, and the other one is for the filtered water. But the problem is that the candle, you have to, once in a while, you have to bring it out and clean. If you use it continuously, it may lose its effectiveness. And then sand filters are also good. Then, but perhaps the most ideal is the chemical disinfectants. Using say chlorine. But the problem, okay, so chemical disinfectant will have that residual disinfection, which means that even if the water is contaminated, the residual disinfectant in the water will take care of the contamination. But the problem is that it has this taste of chlorine. And some persons may not be comfortable with that chlorine taste. Okay, the commonest one we have in Nigeria is this water guard. Water guard is good because water guard contains not just the chlorine, but also a coagulant, which means you can use it for turbid water. Water you fetch from a pond. Water you fetch from a pond, you can make it cool, because if you the coagulant alum will make the particles to settle, while the chlorine in it will just will kill the microorganisms, meaning that it is good. So if for field study, if you are carrying out any field study, you are traveling into your community, with a poor water supply, it will be better for you to go with a bottle of water gas. It will save you from all the waterborne diseases we mentioned. Then a lot of our households don't have pipe-borne water, so they store water. The best container to store water is like a jerry can. It's a jerry can. It's a jerry can, because you don't dip into a jerry can. Dipping actually contaminates the water. So containers that prevents dipping, like jerry cans, are encouraged. So if you, apart from jerry can, you can actually put a tap into a container, so that you don't dip to fetch water, but you can turn on the tap. So these are recommended, and these are the recommended way of storing water in a household. These are recommended ways of storing water in a household. Okay, so we have gone through water. We have gone through that. Do we have any questions, comments? Questions, comments? Okay, I think that is Alexander. Hello, Alex.
Good evening, Prof.
Good evening, sir.
Okay, Prof. I'm confused. I'm a master's student in occupational medicine, and I just saw them post this new course newly on our occupational medicine group. But during my course registration, it's not part of. I didn't see this stuff.
I think it's a mistake. It's a mistake. It used to be, but not.
Okay, sir.
Yeah.
So we should. The MPH and the occupational medicine student we do the course, right?
No. It's not for occupational health. It's not for occupational health.
Not for occupational medicine.
Yes, it's not for occupational medicine, please. But we had to include occupational health in it to give those in the MPH class the exposure. I think it was the source of that is the source of the confusion.
Yes, because they posted it on our occupational medicine group.
No, yes, just tell them that you are not to take it.
Okay, sir. All right, sir. Yeah. Thank you, sir.
Okay. Well done. Okay. Yeah. Do we have any question? Any question? Okay. Hello, Loretta.
Good evening, sir.
Good evening.
Thank you very much for your lecture. Sir, just one question. I want you to throw more light on reverse osmosis for residential areas. Does it kill microorganisms, or is just for the chemical?
I think reverse osmosis is usually meant for those chemical contaminants, because what it does is to absorb the chemicals in the water, draw them out of the water, Yeah, yes. They are not mostly used for microorganisms. For microorganisms, the different types of disinfections are used, like physical disinfection. They use ultraviolet rays, and then for chemical they can use ozone and then chlorine. Okay.
Thank you, sir.
Okay. Thank you. Um, I'm tempted, so since we need to, okay, let's not go into the sewage. We are going to end here today. Tomorrow we are going to fire on, and the way this thing, the way we are going, we 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 will see how far we can go. But don't let us finish this course this week. Eh? Don't let us. If you don't ask question, I fire on, and if I fire on, we can just finish. So that is a problem. Hello, Anne. Hello,
Yeah,
Anne.
good evening, sir. Happy New Year.
Yes.
Yeah,
I have
sir,
this
please, I have
tracker one. Yes, but go on.
yeah, so I have a concern with the time of the lecture. The 4
Yeah.
o'clock that is slated for this lecture is actually not favoring most of us. Please.
Most like you took an
Yeah,
opinion
like
to.
me, yeah, because by 4
No,
o'clock I'm still
no,
at work.
no,
Please.
ma. No, ma. He said you took an. He said most of you now. Did you
Okay,
take
so
an
let me speak
opinion
to my
to? Actually,
let me speak to myself.
madam, this is the last course. In fact, I was just thinking that um, the way he's going, perhaps we have to cancel tomorrow's lecture, and probably have it once a week, and then when we come, we do revision and we go. But you know that this is just the last. This is the last. And we have the other programs. They have actually finished their courses, and we have entered the short courses. So we don't want to be for it to clash, So that is the thing. That is the reason for the shortening. Okay. Tracker. Hello, Madam Tracker. I don't know if the Madam or guy Tracker. Tracker one.
Good evening, sir.
Good evening.
Okay, so sir, even though I just got the information that this is not for occupational medicine, but since I listened through the class, I just wanted to ask. So for boiling of water, the rolling boil would be what temperature would we link to a rolling boil for water? Because most electric kettles come with they stop at 100 degrees. But
Okay.
assuming someone is boiling water and wants to use a thermometer to check, what would be the temperature of a rolling boil?
Anyway, when we in public, especially in public health in our environment, we have to use indicators that can easily be applied. I know that I've seen thermometer for the kitchen. Yes, that's separate from the one you are used to in the hospital that can actually measure up to that. But they are not common. They are not common, and that's why we say rolling. Rolling boil is that there will be some movement, and I'm sure that what makes the electric kettle to whistle maybe indicative of that rolling, because that is the agitation that causes the electric kettle to whistle. So when we make such, it's just to ensure that even the illiterate should be able to understand. Yeah.
Okay, sir. Thank you, sir.
Hello, Alex. Alex, you are still enjoying the lecture.
Yes, sir. Sorry, this question I'm going to ask is not pertaining to this lecture. is pertaining the short course, sir.
Okay.
Because when I was doing my course registration, sir, I took one elective, which is climate change. So I remember you saying that, okay, those electives will be converted to short courses, and we have one free short course, and we can pay for the rest, and there will be discount. So when I went to the site, after I selected climate change, I selected two other short courses I want to pay for, but the site keep charging me for that climate change. So what I did, I just registered for the two short courses I want to pay for. Then I filled another form again and just selected the climate change, but I didn't pay for it. So I don't know how we can go about this, sir.
Alex, the problem is that we are finding it difficult, and the IT persons, I'm sure they are also the one making it difficult, And then for the one that is supposed to be free, we wanted it to leave it at the discretion of the students. But I think we are beginning to understand that certain programs need certain courses, at least to complete their curriculum, and that's why we said those in environmental health and epidemiology, they have to do public health laboratory, and that means that we have made the public health laboratory the free course for them. This is actually a letter decision. It's a letter decision. So yes, it's a letter decision. And so all those things we are finding it difficult, but we'll continue to interface with the IT person to see if there are ways of applying these things. But it's a common problem. Okay. Thank you.
Okay, sir. Sir, sorry. Is there a way for them to check out the course registration most of us did to know, okay, which one was selected as elective earlier?
No,
know how to
no, it will not, because some of those electives would have changed. But to tell you the truth, those short courses, we called people to come and package them, and we were unable to get people to package some of the courses. So the ones we have now are the ones we have we are ready for. We don't want to run into the problem we ran into last year, where we advertised courses, even some people paid for them and they were not given. So unfortunately, we cannot go back to those restrictions. I must acknowledge that we have been the ones making those flip-flops. We have been the ones making those changes.
Okay, sir. Thank you, sir.
Hello.
Okay. What of if? Sorry. Lastly, I will not disturb again. Like for what I explained, that I picked two that I paid for. Then and I did the second one. I just picked only climate change. I didn't pay for. If at the end of the day you have to pay for those courses, is there means for me changing the initial two I picked for, maybe one of them to climate change and the other one and leave it the way it is?
I don't know. We think it's a problem that we have to brainstorm and think of the best way to resolve it.
All right, sir. Thank you very much, Prof.
Yes. Hello, Chukwemeka.
Yeah, good evening, Prof, and Happy New Year, sir. Okay, so my question is also in regards to the short course. You mentioned that a public health laboratory is free for those in environmentals. I don't know, is it the same for us? I would like to know the one that is free, because I tried registering the free one and I was still asked to pay. So which of the courses is free for us in public health in MPH? Thank you, sir.
No, we wanted to make that the free course to make it just to put it at the discretion of the students, especially